Hello friends, this is Priyanka. Today we are going to draw analogous electric circuit with force current analogy. In this video, I will tell you some important tips regarding how to draw analogous electric circuit from the equations. These important tips you can apply each and every question related to force current analogy. So please watch this video till end. Let us first understand what is the given mechanical system. Now if we observe this system, here is the applied force F of t, here mass m1 and having displacement x1. This m1 is attached with this spring, stiffness k1 and damper with viscous friction coefficient v1. In between m1 and m2 there is spring with stiffness k3. m2 is having displacement x2 and m2 is connected to spring with stiffness k2 and damper with viscous friction coefficient v2. In between m2 and m3 there is spring with stiffness k4 and m3 is having displacement x3. So let us first draw the free body diagram for mass m1, m2 and m3. Now if we observe mass m1, applied force is F of t. So because of this applied force there is also the reaction forces. So which elements are responsible for the reaction forces? Now if we observe inertia force due to this mass m1, then spring force due to this stiffness with spring k3, then spring force due to with stiffness k1 and damper force with viscous friction coefficient v1. So we have to show all these forces, but these are the reaction forces. So we have to show in opposite direction of this applied force F of t. So I will show here. Now first we will take inertia force due to mass m1, then spring with stiffness k3, that is fk3, then fk1 and fb1. Now I will write the equation. So according to Newton's second law of motion, action force F of t is equal to addition of reaction forces, that is fm1 plus fk1 plus fb1 plus fk3. Now these all forces we have to define in terms of displacement. Input is force F of t and output is in terms of displacement where x1, x2 and x3. So we will define all these forces. So what is the force due to inertia force due to mass? So we know that m d square x by dt square. But here mass m1 is there with displacement x1. So how we can write here? That is m1 d square x1 by dt square plus spring force k1. So force due to spring, that is k into x. So x is x1 because k1 is connected to mass m1 which is having displacement x1. So I will write here k1 x1 plus force due to damper. So here b dx by dt. So instead of x I have to use x1 because b is connected to this mass m1. So I will write b1 dx1 by dt plus fk3. Now k3 is in between m1 and m2. So we have to take the difference in between displacements. Now this is the free body diagram of m1. So while taking difference we will take x1 first. So for this k3 I will write k3 in the bracket x1 minus x2. So this is the differential equation. I will give here equation number 1. Now we will move for the next mass m2. So this mass m2 is connected to spring with stiffness k3, spring with stiffness k4, spring with stiffness k2 and damper. So all these elements are responsible for the reaction forces. So we have to show all these forces in the opposite direction. Now this k3 is attached to this left hand face of this m2. So I will show here force due to reaction force due to spring with stiffness k3, that is fk3. Then all the other forces I will show here. So first we will write here inertia force due to mass m2, that is fm2, then fk4, then fk2 and fb2. So all these reaction forces. So according to Newton's second law of motion, we can say sum of all the reaction forces is equal to 0 because all the forces are in the same direction. So how we can write here equation? So I will write here Fm2 plus Fk2 plus Fb2 plus Fk4 plus Fk3 is equal to 0. Now we have to define all these forces in terms of displacement. So inertia force due to mass m2. So m2 is having displacement x2. So I will write m2 d square x2 by dt square plus k2 is connected to only m2 which is having displacement x2. So I will write k2 x2 plus here b2. So I will write b2 dx2 by dt plus k4. So k4 is in between m2 and m3. So I have to take the difference in between displacement. But this is the free body diagram of m2. So I have to take x2 first. So how we can write here? That is k4 in the bracket x2 minus x3 plus k3. Now k3 is in between m1 and m2. But this is the free body diagram of m2. So I have to take here x2 first while taking the difference. So I will write k3 x2 minus x1 bracket complete which is equal to 0. So this is the second differential equation. Now we will move for next mass m3. So this m3 is connected to only k4. So k4 is on this left hand side face. So I will show that reaction force due to k4 is Fk4. And there is the inertia force due to mass m3. So I will write here Fm3. So again, according to Newton's second law of motion, the addition of all these reaction forces is equal to 0. That is Fm3 plus Fk4 is equal to 0. So what is Fm3? That is m3 d square x3 by dt square plus k4. Now k4 is in between m3 and m2. So I have to take the difference, but this is the free body diagram of m3. So I will take x3 first. That is k4 x3 minus x2 which is equal to 0. So this is the differential equation, that is equation number 3. So these three equations are important while we are going to draw the analogous electric circuit. Now we will understand how to apply force current analogy. Now if we observe the mechanical system, force is input. Now in the electrical system also, or electrical network also, we have to take current as an input and we have to draw one circuit. So we will take here one circuit where current is the input. That is, here is current I of t is the input and elements resistor, inductor, capacitor. These three elements are parallel to each other. So when these elements are parallel to each other, voltage across these elements will remain same, and that is nothing but V. So how we can define this voltage? So voltage is nothing but rate of change of flux. So this rate of change of flux, that is d phi by dt. So this is the electrical network. So now we have to write one equation regarding this electrical network. So I of t is input and V, that is voltage, is the output, and voltage is nothing but rate of change of flux, that is d phi by dt. So we have to define all these elements, that is R, L and C, in terms of voltage or in terms of flux. So I will write this equation in terms of flux, that is I of t is equal to C d square phi by dt square plus 1 by R d phi by dt plus phi by L. This is the equation. So if we compare this equation with spring mass damper system. So in spring mass damper system, applied force is F of t, and what is the output? That is in terms of displacement x. So how we can define this? That is, we have to define the spring force applied by mass, force applied by spring and force applied by damper in terms of displacement. So here is the equation. F of t is equal to m d square x by dt square plus b dx by dt plus k into x. So I will give here, this is the equation number 1 for the mechanical system and this is the equation number 2 for the electric system. Now we will compare these two equations. Now question is that force current analogy. So force is input and here current is input. So if we consider these two elements are analogous to each other, then we can say that M is analogous to C. B is analogous to 1 by R, because if we observe coefficient d square x by dt square, here d square phi by dt square, then dx by dt, d phi by dt. So we can say that B is analogous to 1 by R and K is analogous to 1 by L. And x is the output and here is also phi is, that is flux is output. So we can say x is analogous to phi. Now while applying force current analogy, we have to write the equation in terms of V. As we know that in the mechanical system we always try to write the equation in terms of x, because here x1, x2 or number of displacement is the output, and here in this case, that is in case of electrical network, voltage V is the output, because when current is input, then in terms of voltage V there is the output. So we will try to write, or we will try to change this flux phi in terms of voltage V. So how we can write here? So this x is analogous to phi. So if I take the integration, that is phi V is equal to d phi by dt. So this is important relation. V is equal to d phi by dt. So if I take on both side integration, then this integration and this derivation is getting cancelled. Then phi is equal to integration of V dt. So we can take here, if x is there in mechanical system, then we have to write here integration of V dt. Then in the same way, if I take dx by dt is analogous to d phi by dt. And what is this d phi by dt? D phi by dt is nothing but V. So if dx by dt is there, then I have to take V in place of dx by dt. And suppose d square x by dt square is there, then I have to take dv by dt. So I will also write that. Suppose d square x by dt square is there, then I have to take dv by dt. So these three are important factors. Instead of x, I have to take integration of v dt. Instead of dx by dt, I have to take v, and instead of d square x by dt square, I have to take dv by dt. So you have to note down these three parameters, because these three are important coefficients in case of mechanical system. Now we will take the first differential equation. So when we consider this first differential equation, how we can write m1. Now this suffix are also important, that is number 1, 2, 3. So we have to take these numbers also while we are converting into this analogous system. So instead of m1, I will take c1. So I will take c1 d square x1 by dt square, that is dv1 by dt, plus k1. So k1 I will take 1 by L1. Now x1 I will take integration of v1 dt, plus b1. So instead of b1 I will take 1 by r1 dx1 by dt, that is instead of dx by dt I will take v. So I will take here v1, plus k3. So instead of k I will take 1 by L3. So this suffix is important. So instead of L I have to take L3. Now x1 minus x2. So instead of x I have to take integration of v. So here also I will take the difference, that is integration of v1 minus v2 bracket complete dt, which is equal to, now f of t is nothing analogous to I of t. So I will take here I of t. So this is the electric this is the equation, differential equation for the electric system. Now we will try to draw the analogous circuit. So we have to draw the three analogous circuit regarding these three differential equations, and then we have to combine. So first I will try to draw here. If we observe this C1, that is capacitor C1 is along with voltage V1. So I will write here C1 is along with voltage V1, because here if we have to observe this coefficient, then L1, so this L1 or 1 by L1 is along with V1 only, so I will write here L1 with V1. Then this R1 is also having coefficient only with V1, so I will write R1 with V1. Then L3, so this L3 is in between V1 and V2, because for this L3 the coefficient is in between V1 and V2, so I will write L3 is for V1 and V2. So now these are just we have to note down the points to avoid the confusion. So this is for the purpose to draw the diagram. So for this C1 is along V1, that is capacitor C1, inductor L1 and this resistor R1 are having same voltage V1. That means we can say that these three elements are parallel to each other. So we have to draw this. So I will draw here C1, L1 and R1 parallel to each other. So first I will take R1, then I will take here L1, and then I will take capacitor C1. So these three elements are parallel to each other. Now input is I of t, so we have to give input also. So initially we have to write here as a input I of t. Then L3 is in between V1 and V2. So across these three elements I will show here voltage V1 is there. So I will use here different color marker. That is across these three elements voltage V1 is there. Now if I extend this, then after that V1 there is L3 is in between voltage V1 and V2. So we have to draw L3 in series with these three elements. So how we can draw here? That is in series, that is here in series with this V1 I have to draw the element L3. So here is L3 and on this side of this L3 there is voltage V2. So I will show here along this vertical line only, we can show also the voltage V2. Now if we observe, we can satisfy all the elements, that is I of t is the input, then C1, L1, R1. These three elements are having same voltage V1. L3 is in between V1 and V2. So in between V1 and V2 we have to join this L3 in series with these three elements. Now we will move for the next circuit. So for next circuit again I will write the analogous electrical equation. So here instead of M2, so M2 I will use C2. d square x2 by dt. So d square x, that is dv2 by dt, plus k3. So instead of k I will use 1 by L3. x2 minus x1. So instead of x I will use integration of v dt. So I will use integration of v2 minus v1 bracket complete dt plus k4. So instead of k4 I will use 1 by L4. Now x2 minus x3. So x2 minus x3 is nothing but integration of v2 minus v3 bracket complete dt plus b2. Now instead of b2 I will use 1 by r2 dx2 by dt. Now dx by dt is nothing but v. So I will use v2. Then plus K2 X2. So K2, that means 1 by L2, and X2. So X2 we will use integration of V2 dt. Integration of V2 dt, which is equal to 0. Now if we observe this equation, we can say that C2 is having voltage V2. So I will write here C2 is having voltage V2. Then this L3 is having voltage V2 and V1. So L3 is in between voltage V2 and V1. Then L4 is having voltage V2 and V3. Then R2 is having voltage V2 and L2 is having voltage V2. Now if we observe this C2, R2 and L2 are having same voltage V2. So we have to draw that. And then L3 is in between V2 and V1, L4 is in between V2 and V3. So if we observe for these three elements, that is C2, then R2 and L2 are having same voltage. So we have to draw these three elements in parallel to each other. So we will first take these three elements in parallel to each other, that is C2. So I will draw here circuit. Here is C2, then R2 and L3. So these elements are parallel to each other and voltage across them is same, that is V2. So I will show here the voltage across them. I will use here different color marker. Voltage across these three elements is same, that is V2. Now if we observe this L3 is having voltage it is in between voltage V2 and V1. So here is the starting point. So here is also voltage V2 and here is also voltage V2. So voltage V1 is before that. So if we observe, we have to connect this L3 is in series with this connection. So I will connect here this L3. So here is L3. So before this L3 there is the voltage V1. So I will show here with this vertical line also. So with this vertical line here voltage V1 is there. So in between voltage V1 and V2 there is L3. And then these three elements are having same voltage V2, and again in between V2 and V3 there is L4. So at this point there is V2. So after that voltage V3 is there. So in between voltage V2 and V3 I have to connect here L4. So I will connect this L4, and at this point voltage V3 is there. So I will show this voltage with the vertical line also. So here voltage V3. So this is the electrical network for the second differential equation. Now we will move for the third equation. So third equation is m3 d square x3 by dt square plus k4 x3 minus x2. So instead of m3 I will take c3 dv3 by dt plus 1 by l4 v3 minus v2. Now if we observe this c3 is along with voltage v3. So I will write here C3 is having voltage V3 and L4 is having voltage V3 and V2. So we can say that L4 is in between voltage V3, V2 and V3. So I have to show that. So here after voltage V2 there is L4. So I will again draw here. So suppose we will consider at this point the voltage V2 is there. So in between voltage V2 and here is V3, then I have to connect here as a L4. So here is L4. And then after that there is C3. So for this capacitor C3 the voltage is V3. So I have to show here capacitor C3. So I can say that along this capacitor C3 there is voltage V3. So with the help of vertical line I will show here voltage V3. So this is the first electrical network, this is the second and this is the third. Now we have to combine this. So how to combine this? So first input is there. So I of t, we have to start from here. So after that, here, all these three elements is having voltage V1. So along this line there is voltage V1. Then again in between this voltage V1 and V2 there is L3. So we have to show L3 in series. So here voltage V2 starts. So after this L3, so if we observe for the second electrical network, then here it starts from voltage V2 and again after that we have to connect C2, R2, L2 in parallel. So after that when we connect C2, R2, L2, these three elements are having voltage V2, that is same. After that we will connect here L4 and when L4 is in between V2 and V3 and then we have to show capacitor C3 which is having voltage V3. So we will combine all these three electrical networks. So this is the combined electrical network where voltage V1 is at this point, then voltage V2 and here is voltage V3.